This is a diaphragm seal pressure gauge. Let's break down what it is, how it works, and its working principle. What is it? It's a pressure gauge that uses a diaphragm seal to isolate the sensing element of the gauge from the process fluid. This is particularly useful when dealing with corrosive fluids. The diaphragm seal prevents the corrosive fluid from entering the gauge and damaging the sensitive components. Viscous fluids. Viscous fluids can clog the gauge's Borden tube or other sensing element. The diaphragm seal provides a larger surface area for pressure transmission, minimizing clogging issues. Fluids with suspended particles. Similar to viscous fluids, suspended particles can clog or damage the gauge. The diaphragm seal isolates the gauge. High-temperature fluids. The diaphragm seal can be remotely mounted, protecting the gauge from high temperatures. Sanitary applications. In food and pharmaceutical industries, diaphragm seals allow for easy cleaning and sterilization. How it works. 1. Process pressure. The pressure in the process system is applied to the diaphragm seal. 2. Diaphragm displacement. The pressure deflects the flexible diaphragm. The degree of deflection is proportional to the pressure. 3. Fill fluid transmission. The space between the diaphragm and the gauge's sensing element is filled with a non-compressible fluid, typically silicone oil or glycerin. The diaphragm's movement transmits the pressure through this fill fluid to the gauge. 4. Gauge measurement. The pressure is then measured by the pressure gauge, Borden tube, bellows, or electronic sensor, and displayed on the dial or outputted as an electronic signal. Working principle. The working principle relies on Pascal's law and the elastic properties of the diaphragm and the gauge's sensing element. Pascal's law. Pressure applied to an enclosed fluid is transmitted equally and undiminished to all parts of the fluid and the walls of its container. This means the pressure applied to the diaphragm is transmitted through the fill fluid to the gauge's sensing element. Elastic deformation. The diaphragm and the sensing element, e.g. Borden tube, are elastic. They deform under pressure and return to their original shape when the pressure is removed. The amount of deformation is proportional to the pressure, which is how the pressure is measured. In summary, the diaphragm seal acts as an interface, transmitting the process pressure to the gauge while isolating it from the process fluid. This allows for pressure measurement in challenging applications where a standard pressure gauge would be unsuitable. Key components in the image. Pressure gauge. The circular dial with the pointer indicating pressure. It displays pressure in both psi, pounds per square inch, and bar, a metric unit of pressure. Diaphragm seal. The lower, circular housing attached to the gauge by a threaded connection. It contains the diaphragm and the fill fluid. Threaded connection. The threaded portion at the bottom of the diaphragm seal is used to connect the assembly to the process piping or equipment where the pressure is to be measured. Capillary tubing. Not explicitly visible. In some cases, the diaphragm seal might be connected to the gauge via a thin capillary tube, allowing for remote mounting. This combination provides an effective and versatile solution for pressure measurement in a wide range of industrial applications.